So now let's move to our local expert, Assistant Professor Jonathan Natanian. Uh, uh, Let me just introduce officially. Professor, you already spoke the previous introduction. So Dr. Jonathan Natanian is an architect, assistant professor, and head of environmental performance design lab at Natanian. He earned his master's from Architectural Association in London and completed his PhD at Technical University of Munich. His research focuses on advancing sustainable design through digital and environmental methodologies. Let's welcome Professor Jonathan Natanian.
Thank you very much, Naga. And funny story, when I started my PhD, I wanted to learn more about urban environmental intelligence, and I ran across a paper by, that's why I call you Shi all the time, because Z, Shi. So Ming Shi, building an environment, your review paper. So this is a really nice closure, because since then, also in my PhD, but also later on, I've been thinking about this integration. Like, we have this kind of methodologies which we have been using for centuries how to design buildings, and now comes computation and data. And how do we integrate these things? Take this in roughness. Why rough? Why I ask this question, rough is enough, because I think this is a really important balance between accuracy and reliability that we have, and speed of calculation and the integration of all of them into the design. So balancing speed and accuracy is the theme of this short presentation. I actually have 15 minutes. And I'm gonna start with the background of how we got there and what we are doing, who we are. It's a team effort, it's not just mine. It was, back then it was in a PhD, but then it got expanded, and it's really, really, really great. And then we have questions. I'm asking questions all the time. Questions worth asking. Questions I want to ask with you. What questions I want to work with practitioners on and with scientists, because we need to keep asking these questions and then show you some future ideas of what's next, future applications, and what we're doing. My personal background is that I'm closing here a circle from studying here. I also met Abraham back then, so it's really nice to catch up again. And I went to practice. I worked in practice many years. And then I felt that the way we integrate with environmental design ideas, although I supposedly designed sustainable buildings according to local codes, that led me to the AA, where, Simos, I showed you his diagram, this triangle of knowledge, taught us to be sort of like the Jedi Knights of sustainable design. He did like that. You sense humidity, you sense the air temperature, not just simulations, right? This triangle of knowledge. And then it shifted me to something else. I came back here to Israel. I realized I cannot come back to Moshe Tzur, wonderful office, big projects, nice salaries. And then I started doing research, and that research led me to do a PhD in Munich, and then later on to establish this lab, which is one floor down. You are all welcome all the time to drink good coffee and etc. And it's a team effort, and the team is growing. And you met Naga and Elam already, but we have also Hari here and Amir here. Is working on a paper I'm going to show you next in the lab now. and so, yeah, and we are working in this kind of triangle also of knowledge, of data acquisition, and then the data that we measure, the empirical data, is used for computational analysis, using a lot of artificial intelligence, which is kicking in, but we are controlling it, and we try to understand where do we work with black box models, and then where we start to engage with practitioners, and we do that with this environmental design interface. So how can we interact data? Environmental performance data is a really other important subject worth studying by itself. That's how we see it. And this discussion between, intelligence and intuition because we are talking to people who said, listen, we knew how to design buildings long before we used all this kind of false color diagram. But, things get complicated, especially when we're talking about urban environmental intelligence, and we need to optimize and we need to integrate, and we have multifaceted ideas that we need to combine. What are the performative implications of architectural design? So this is a question asked by architects to the environmental engineer. And what is the spatial implications of this kind of high level, zero energy, zero carbon design? This is the question asked by architects. And sometimes it's the same big office where they have an architectural department and environmental engineering department, they don't connect. So this integration is basically what we are doing at the lab in all our projects. We ask questions, for example, the double side of the sun, the double-faced sun by Le Corbusier is really strong here. The guests I picked up from the hotel told me, what are you talking about? This is a really nice weather, right? Jacob, this is nice, but come in August. I dare you.
No, wait for Saturday.
Come Saturday. Jacob is leaving on Saturday morning, but yeah, but Bigger will experience this, hopefully not with this black clothes. And then, but we need to think about the skin also of our buildings corresponding to that double-faced sun, that we need the sun for certain reasons. I won't go into that. You feel it, you all know it, but you need to block the sun. And how we can do that when we think about doubling our built environment in the next 30 years. Doubling our built environment is a good question. How can we be compact and performative? I told you about this urban compact dream and the reality, thinking about microclimate, but not just microclimate. We have a lot of metrics. What is environmental performance? Only on energy, me and she can come up with 5 and 10 here, and Abraham can come up, 3 of us can come with 10 metrics, right? Is it carbon? Is it plug loads? Is it only HVAC? We can talk about a lot of questions about what is environmental performance, what is the criteria, and there are few criteria, and what is the metrics for those criteria, what are the indicators, but most importantly, also for me as an architect, working here and also with architects, what is the correlation between the decisions architects do in early design phases and the environmental consequences? And how can we be dense and performative can be answered in different kind of perspectives. Is it just energy efficiency? Is it just energy balance? Is it more regenerative design? Can we think about tools that integrate urban environmental performance rather than generating new tools? That was a question I had in my PhD. And the questions I had and I answered when I was doing the PhD is how can we use, for example, Grasshopper to investigate the same density, but looking at 4 different kinds of environmental criteria and trying to optimize them, thinking about the trade-offs between them, because there is no one absolute truth. And sometimes the changes that we will see are marginal, are small. So maybe we have a really small improvement in energy, but look what's happening in daylight, for example. Environmental quality is becoming important, not just energy. Looking beyond energy, that was actually the name of my work there. And then I moved on, also with the help of friends who are specialists like Thomas Wortmann in ICT Stuttgart now, who is a specialist in optimization. Also optimization, I think, is like an area of research, and we have Guy Osten here by itself, using artificial intelligence, other methods, but we need simplified metrics. So I started thinking about how can I develop simplified metrics with high correlation to this kind of full simulations that then I can later use. There is a list of them driven in this. It's very contextual, like what she said, because this is working for our context, where the sun is what I told you, what it does, what I told you it's doing. So we can use solar radiation to indicate a lot of like environmental design criteria that can help us reach these optimizations at this level. And then we can use different algorithms, and then we can also think about their validation and think about how we measure the performance of the optimization, not just the results. which is becoming important. Then we moved on, thinking about mixed use. How can we be diverse? Because what Xiaoming showed you is really important. We want to flatten the curve. So we have different energy curves, and by design, also I really like by design, because by design we can flatten this curve in a block scale when we think about the distribution of different uses, both temporally and spatially, and then we can do this kind of optimization, generating a Pareto front. Pareto front is a range of solutions. It's not just one solution. And here I think there is a nice combination between between the analyst and the designer. Then we can start observing different kinds of situations where we're flattening the curve, as I said, between generation and supply, and reach a spatial consequence or a spatial outcome that we can work with. So this is financed by the Ministry of Energy, and we move from the block to the district and optimize it, and then we can take the Pareto front results and then analyze it based on other considerations. Let's think about other things, not just environmental. Let's think about proximity or views to the ocean, which is really important when you design in Tel Aviv. This could be even a driving force. Or let's think about cost, about the volume to surface ratio, the shape factor of the building, and other things. Let's think about carbon. In Israel, we currently almost neglected. The other thing I started looking at is this pixelated design driven, of course, by, as I call it, intuition. Why? Because the sun could not be just one line in a certain time of the year. The sun is a whole spectrum of spatial and temporal combinations. When we want the sun on certain surfaces and when we want to avoid the sun in others. And this led to really interesting research also financed by the Israeli Science Foundation on generating or a generative approach using Grasshopper that generates like a series of buildings which are different than the solar envelope, which generates only a boundary, right? This for me is a solar envelope. It's just one line in the 21st of December that says, if you design here, you're good. It's a boundary. We are designing buildings, and we are doing that now. We're developing it from the block to the district, and we are testing it against the design with solar masses and see the benefits. And this is not clear cut. Sometimes designing with the mass as it is now here is better, actually. We're in a situation where we need this kind of long roofs, for example, for PV generation. So if you have this pixelated massing, it can yield worse results. So we are discovering and revealing it now on a new paper. This is the image of it. And then how can microclimatic conditions be effectively integrated in all of that? Microclimate is big, it's changing also the way we interact with these energy simulations. There is a double impact between the interior and the exterior, which people neglect when they're taking the climate file from Beit Dagan. There is microclimatic conditions outside every point and every window in your building. And this is what Elam and Naga are interacting with. This is not me, I'm doing it through them, with them. And in this case, also with Bige, who is a co-supervisor of Elam. This is great because it looks at the form. And then it says, okay, there are different kinds of facades that we can put in this form, and we can cluster it according to different kinds of microclimatic conditions, right? Some places are more shadowed, some places are more exposed. And how can we optimize this clustering of the facade? And the message is really clear. Look at what's happening outside. Even if I'm putting shading on buildings in Israel, the shading looks the same in all facades. This is in case we have shading, yeah? Search for these buildings, but even that. So the idea is that the uniformity of the shading strategy could be different. It could be aligned with this strategy that will inform it is a very valuable contribution of Elam. Another very, very important contribution is the one by Naga for energy modeling. So for example, if we want to model energy performance, how can we simulate or taking into account the microclimatic conditions we have outside each window? So this is another really important work done with machine learning that generates a data set of a lot of runs using AgriMet, and then finding a meta model that predicts the microclimatic conditions around buildings. And this can also be used later for microclimatic or outdoor thermal comfort models. And this is also extremely ambitious and interesting. Another thing we are doing is the environmental performance interface. How can we effectively interact? How can we interact with, I see practitioners here from an architecture office who have their R&D department, right? This is great, welcome. And how can we work with you when we have all these layers of data for 8,760 hours of the year? This is too much. We have wind, we have solar emission. How can we balance between them effectively, interactively? And this is what we are also developing, such platforms. We're using also here, Hologram, for example. We have our own dashboard. These are the simplified metrics I just talked with you about. They help us look at different kind of solutions. And now in CMOUT, in Madrid, we're gonna, oh, we don't have it here, so this is the other version. Never mind. So we are doing these parallel graphs as a design explorer that will help us do it interactively. So we can minimize the range of the solutions and then see the solution when walk around it. And we are experimenting and also inviting a lot of people to talk with us, to try with us, to discuss different kind of solutions. So this leads me to the last part of my presentation. Yeah, I think I'm on time. Oh, I did it out. So human-centric, nature-based application, only 3 more slides. One of the areas we want to further develop is the human-centric design. Humans interact with, buildings, and humans consume energy, and we need to think about this kind of interaction. And also, I think the idea is that a lot of bias is going on, not just bias, uncertainty is going on, you're right? There is a performance gap. And if we learn how to work, this is also a prediction of how people will interact with the simulation-based modeling. But this is work with David Schaumann, who's not here today, unfortunately. But this could really lead into interacting with the human approach or a human scale in order to integrate it in our predictions. This is one. The second one is starting now with Harry, who is here, and the idea of vegetation, how vegetation interacts with everything. And my idea is the way I optimized massing with you just now, the past 15 minutes, I want to optimize masses of buildings and trees. Where to place the park, where to place the open area, where to place the tree next to the building in order to achieve a preferred combination in terms of different kind of environmental criteria. Let's work with the landscape architects. I'm saying it to myself because we have landscape architecture here, and we can do great things together, actually improve and enhance. This is regenerative design, right? It's not just reducing energy efficiency, it's improving the conditions. And I'm really happy that we started working with the National Urban Renewal Authority that actually works on these kind of districts and help redevelop them. And they believe in us, and I'm really thankful for them for putting trust and money in our lab. And we are working with an architecture office in the outset of a project, which is just starting now. We're going to be integrated, and we're going to be delivering data from the beginning in order to make decisions. And this is really exciting. And we're happy to report it next time we meet and hopefully write a paper out of it, because I think it's also research. This research has its own right to exist because this is unexplored. How do we integrate all these kind of things? It really connects to what Jean-Ming showed with the students, like students as clients, and also architects as clients, real architects that we work with. And then I think we could generate a lot from that. So yeah, again, this, like I would say, more old methodologies, not old, but traditional methodologies, and the intuition we have as architects, combined with this digitalization and finding the right balance. So this is, I wanted to write here that this is not done with ChatGPT. And in the other version I have, which was not downloaded, there is a version done with ChatGPT. And the difference is really interesting because when I clicked and I asked for ChatGPT to create it, it generated this mesh, like a potato mesh of all these videos. So we have to be really minded to where like the computer or AI ends and we begin. Thank you very much.
Thank you so much, Professor. Every time we listen to Professor Jonathan, we have certain kind of takeaways. For example, if I'm from the data science background, like, okay, I have a bachelor's in architecture, but I have a master's in information technology. So first time when Professor Jonathan introduced his research, the first key takeaway, I was like, oh, we can also derive a new KPIs to reduce the simulation time. No need to use a cloud or something. So this was a key takeaway. So many of you would have your own key takeaways. And now I'll open the floor for the question session.
I wanted to ask, you mentioned, the last thing you mentioned was an urban renewal project, and you said you were going to be collecting data. And I wondered what type of data and how you're going to collect it.
Very, very good question. We are going to produce data, not select data. We will get the data from the architects and the National Urban Renewal Agency. And according to that, we will perform our own optimization. And this is interesting. Like I'm taking your question, using it a bit, but the idea is that we have together is which kind of constraints we need to take into account when we are conducting or when we are applying all these really nice floating animations I just showed you in real life. There are constraints. For example, our clients told us immediately when I showed them the courtyard typology, they told me, but we have to have at least 3 directions, like orientations open in this case, in this place, because otherwise it will not be economically viable. So this immediately changes your optimization. So this is the kind of data we want from them, the real life data that shows the applicability of all that in real life. Thank you for the question.
Jonathan, thank you so much. This was really a very exciting presentation. I loved it. I have a bit of a detailed question. The application that you showed, which uses AR and the discussion around the table, in that image, there were also some VR goggles. Am I wrong about this?
You're right.
Can you tell me a bit about how you combine the AR and VR in such a context?
Yes, it's not actually VR, it's XR, it's extended reality. So the idea is that it works the same. You look either on a physical model, and then you can just show the empty slot you want to plug in your design. And then you can look at different kind of variations of this design and get also different indicators running in the background when you see it, when you look at it. But we really came to a fast conclusion that we printed actually a physical model. It took us a month to 3D print all the buildings. It takes half of our table, but in the end of the day, you don't really need a physical model. You can just work with, a usual extended reality or ordinary just to have this kind of simulated model. And then we use this, but we can do it also with iPads. I have to say that I saw this idea, I picked this idea also by the work of City Intelligence Laboratory, which is heavily influenced this module that we developed, also with the work of Angelos Chonis, who also now integrates it in infrared. I think they are also doing great stuff in this direction. And yes, we're trying to figure out what's the best way to do that. And there was this goggles by Apple, but apparently the software is by Hologram, that they don't work with the Apple goggles. But I have to give credit to Hologram, which they developed the tool. So we did not develop the tool. We always find that like developing tools a bit challenging and outside of what we do.
Thank you.
Yeah, the next. Vishakar.
Hi.
I have a broader question and the context that we are talking about urban intelligence, urban environmental intelligence. But why are we not talking about the sustainability of the water and the air quality index in this whole thing? Everything is just focused on the energy conservation, energy, maybe better use of energy and all those aspects. What are the criteria that should be considered while we are just considering about water and air and in making the urban environment better accordingly?
Great question. I think the idea of this workflow, which by the way, I'm not owning it. I think it's just an idea which is also out there and it's developed by all of us, is that we are working with workflows which are really dynamic. So this is the beauty of working, for example, with Grasshopper, that you can measure one thing with another. You can put X plus Z. It doesn't have to be X plus Z. There is a list, X, Z, Y, whatever you want, alpha, beta, air quality, water quality. And yeah, I think, for example, the thing I'm missing, I'm always looking at my work and I feel that I'm missing something. The thing that I'm missing is this: if we want to say that we want to reach zero carbon 2050, we have to put carbon into this analysis. And this might change also, the reference point, it will change the optimization. This is one thing. Second thing, we have to put vegetation into the equation, right? And the vegetation will impact a lot of other things, for example, daylight availability. So these two phases of everything, and we really need to be able to think about things holistically. So you're completely right, but this works exactly with what I intend to show you here. It's the possibility to explore certain things, many things together.
I have a question. Can we take two online questions? Actually, we are.
Maybe we can
attendees,
get it. Maybe this question will be answered in the panel, because we have a panel discussion.
But we have time to take offline attendees, like in-person attendees, you can meet Professor Jonathan and put forth your questions. So that's an opportunity for online attendees. So there is a compliment for the great presentation and asking, I'm curious whether this workflow is also flexible enough to incorporate more contextual and subjective criteria, for example, aesthetics or historical character of the surrounding buildings. Have you encountered such aspects in your work? And if so, is the workflow adaptable to include these more qualitative considerations in the generation of building blocks?
Was it sound?
Sorry?
Historic what?
Historical character of the surrounding buildings.
Okay, so yeah, the thing is that there are a few different approaches. One approach is that you can put numbers on everything. Like I remember, I won't disclose the person who told me that in Munich, but a very engineering-driven approach. We can put numbers on everything, and then we can put them in the simulation and say this is, you put it in a spectrum between 0 and 100, and then you say, but another thing we have to think about is how to weigh things, is how to put weights on things, because when you have so many criteria, how do you decide what is the preferable combination? Then you can say, okay, but I bring the designer and he said, okay, let's put historical, like for example, if I translate what you just said, historical building value, so maybe I need a view. I have a view to different kind of historical facades from a certain point in the building. For example, this I can quantify, like sky view factor, or I can have vegetation view factor, I can have view to historical building factor in a historical city. So this could be also very, you can measure it. The question, it becomes a bit more complicated when you put different values which are more qualitative. And yeah, I think this is also an area of research by itself. This is really an easy answer to everything, but it's an area of research by itself.
I think we can ask the last question, online question, and then we can go for the panel discussion. So what would you say is the public uptake of all these kinds of technical analysis? Meaning, how often are city stakeholders and leaders actually using this to inform planning and development decisions?
The question is from which country is this question, right? Because if this is an Israeli question, the answer to that is really sad and most probably not much, right? I don't know if Chen will agree. But it's changing. I see a big change now because also standards are changing, awareness is changing, the goals are changing, and they realize actually that changing things in the early design phases requires less amount of environmental expenditure, and the impact will be the biggest. It's like the upside down pyramid. And it doesn't necessarily have to cost more money if you place the building here or there on the site. And I've been there and I've seen how it's done in real life in a big office. It's really, really random. It's random, I have to say it. So yeah, if we can add some data to this randomness, it's a bliss, it's good. Why not? It doesn't cost more in most cases, at least at this phase, right? That we put the massing. This is what we are talking about. Of course, when we go deeper and think about the detail of the double skin facade and to run a CFD simulation, this is something else. We have all the data, the systems are in. This is before the systems. This is also a question for discussion between me and Zhongming, because what interesting in what Zhongming shows is that they're also integrating the system. So in a way, there is this trade-off between a passive and active design strategies, which is really cutting edge for me. And this is why I really love what you're doing.